Welcome to episode 3 of the Simply CMT Podcast, presented by the Charcot-Marie-Tooth Association. I'm Chris Cosentino, and we have a special episode for you today as it marks the first research edition of the Simply CMT Podcast. Today, all the way from the UK, we're joined by CMTA's Chief Research Officer, Dr. Katherine Forsey. Welcome, Dr. Forsey.
Thank you, Chris, and thank you for having me on the Simply CMT Podcast.
Now, before we get into all the great work that you do for CMTA, let's discuss your research background and how you connected with CMTA.
So this is a long story, really. Well, it can be a short story, but it happened over quite a lot of years. So I think I was 11, apparently, when I said to my mum that I wanted to be a scientist. They have no real idea where this came from because that's not the background of anybody in my family. But age 11, I announced I wanted to be a scientist. And sure enough, I carried on through school and picked scientific subjects. And eventually that led me to doing my first degree in molecular cell biology. But the best part about that first degree was I took an extra year and did a year in industry. And I got to work for a genetic toxicology company called Syngenta. And I spent a year in their research labs. And that's the first time I'd spent time in an extended amount of time in a real working research laboratory. And I ran my own project over that year, which was developing an in-the-dish experiment, an in-the-dish test that they could use instead of an experiment they'd previously done using an animal model. So it felt like a really useful thing to be doing, and that was successful. I developed this new experiment for the company. I wrote it up as my full year project dissertation. When I came back to university to do my final year, and I spoke to my academic supervisor, and I said, I really enjoyed that year doing real science. Like, I've got this project, I wrote it up, and I like being at the lab bench. And I was like, I don't really, what can I do next that's going to carry me on in that direction? And he said, well, have you thought about doing a PhD? And quite honestly, I was like, well, what's a PhD? Because no one in my family's even been to university, let alone done a PhD. So he explained that a PhD would be, in the UK at least, it's 3 more years of research with then some extra time at the end for writing up what you found. And in that time, you pick your subject, and over that time you become the world's leading expert in that subject. And it's so tiny and so specific, and nobody else looks at it in anywhere near as much depth as you do. And the idea is that you have to advance the knowledge within science on that one subject. And I said, yeah, that sounds like a great thing to do. That was 3 more years of sort of being in the lab, doing that science I was really enjoying. Unfortunately, there was an industry-funded PhD came up, and I applied for it, and I got it. So I spent 3 years working between the University of York and my industry sponsor, which was based down at the University of Cambridge. And I also spent nearly a month at a research institute in the Czech Republic. And I did that PhD. I wrote up my research. I loved it, but it was also the hardest thing I'd ever done. And quite honestly, I wouldn't do it again. I mean, some people have 2 PhDs. I just could never imagine myself doing it again because it was grueling getting some of that research across the line. But it gave me a really good training and a really good grounding in science. And I finished my PhD, and I could have gone on and done a postdoctoral research and an opportunity to go to Cambridge to do that. And I'd really just thought about it, but I wanted to get out into the world and put my training and my science to good use, but also to use the other side of my skill set, which for me is working with people, is the conversations, the sort of the broader project management, the using my skills to kind of get things done. And I went into non-profit world. I started working in different projects, project management, running programs, and became a real specialist in taking something from nothing and growing it into something that was successful and self-sustaining. And I did that for a range of different organizations. And then alongside, I opened my own consultancy business. And all this time it was using my skills in science and then my ability to be able to talk to different groups of people. So the community, academics, industry. So having those really complex scientific discussions, then at the same time, sort of making that accessible to the general public. And that was always that running theme through my job. And I think you asked in your questions how that brought me into the CMTA. And honestly, therein lies the power of volunteering. So a few years ago, I put my hand up to be a volunteer counsellor for Camp Footprint, which is a CMTA's camp that we run for young people with CMT. And I met the infamous Jonah Berger, who is the director of Camp Footprint, and he interviewed me to be a volunteer camp counsellor. Random British woman gets on the call and she's like, I want to come volunteer for you in Pittsburgh for Camp Footprint. And we had a really good discussion, and Jonah discovered that I'm a research biologist by training. And at the time, the CMTA happened to have an opening for somebody to do that kind of work. They hadn't previously had somebody in a chief research officer role. It wasn't quick and easy. It was a 3-month process of interviews where we talked about what that might look like and what work I would be able to do and my expertise and my background. But in May 2022, I joined the CMTA as their first chief research officer. And honestly, it still feels like a fairy tale story to me quite often.
Now, stepping aside from research just for a moment, discuss your life with CMT and your approach to managing some of the challenges caused by CMT.
Yes. So one of the things I didn't mention in why did I volunteer for Camp Footprint? It's because it's been 6 years ago, I think now, I was diagnosed with CMT. So before that, it came as a bit of a surprise. It came about because my sister was having some medical problems, and she finally saw a specialist which looked at the whole of her, not just spot treating some of her symptoms. And they really dug into what was going on with her, did lots of assessments, they did a family tree. And she answered all of these questions. And my dad has CMT, but my dad never really talked about it very much. And despite the fact that I have a PhD in reproductive biology and genetics, I still cannot believe that 2 and 2 was never put together. We were never told about the risk of inheritance or like the family history and how that might impact me and my sister. But my sister got her diagnosis. She had a blood test. They told her she had CMT, and through the family tree, they said, if your sister's got children, she might want to consider getting tested. I mean, that's a personal decision for everybody, but I'm a researcher by training. I am in the knowledge is power camp, and I rolled up my sleeve and said, yeah, great. I want to know. Please test me. So my test came back positive, which was a bit of a surprise for all of us, because I present very differently to my sister. And it did make all of a sudden quite a few things started to make sense. So I was like, that's why I can't really feel my toes. I just used to think I had useless toes. But if you think about it, what do your toes feel like? And how do we know if your toes feel different to my toes? It's a completely personal experience of how you feel on the inside. But yes, things started to make sense. And you asked about what my life with CMT is like. I think I feel I'm quite lucky working with the community as closely as I do. I can see the range of ways in which CMT affects people. Mine is mostly sensory loss. So fingers and toes. I can't feel temperature very well. So I can't take my children's temperature by sort of putting my hand on their forehead and thinking, oh, you feel hot. I can't, if I touch my pot plant, see if the soil feels damp. I just can't tell if something's wet by feeling it. Obviously that has some safety risks about, if I walked on something and cut my foot, am I going to feel it? So I have to be careful in that regard. Also my balance isn't great. So balance, coordination, we call it proprioception in the CMT research world. So it's like where my body functions in time and space. Like I struggle with that a little bit. But I've also, the more I've learned about my CMT, the more I've been able to start working to improve my symptoms through exercise. So I've massively been able to improve my balance through strength training, balance training, sort of core fitness. That's made a huge difference to me. And I dance, and that helps me as well. So I think my life with CMT really has affected how I treat my body and how I work hard to manage my symptoms and be proactive in that. And I feel fortunate that I can do that. But CMT affects 4 generations of my family. So most of my life with CMT revolves around concern for my children. I think everybody with CMT, knowing the inheritance patterns, has that concern. So I think I worry more about my children than my own future. But also I think I'm really lucky through my work with the CMTA. I have loads of exposure to what's out there and what's available in terms of managing CMT. So I made the decision to have both of my children tested. And I had to lobby for that because sometimes they can say, why would you get them tested if there's no treatment currently available? But in the UK, it certainly unlocks the door to lots of specialists if you have a definitive diagnosis. So it turned out one of my children has CMT and the other one doesn't. But it means that I was able to take my child with CMT and see the UK's top specialists in CMT. So off we go to Great Ormond Street Children's Hospital. He goes there every year. He has orthotics in his shoes to help with his foot alignment. He wears night splints to help maintain his dorsiflexion, which is the sort of angle that he can flex his ankle. Because kids grow really fast. And in CMT, we sometimes have problems with stretching and tightening and trying to maintain that flexibility around our joints is really important. So it meant that, like I do for my health, I can make sure that for my eldest that we are proactive in how we manage his CMT to keep him stretched and mobile, and in knowing that hopefully means we can avoid some of the surgeries that are quite common for people with CMT, where they need to have tendon lengthening and things like that because their flexibility is really declined. So I'm hoping that we can keep him stretched and mobile until he stops growing quite so rapidly, and starts to being able to hold stretches for the right amount of time and sort of be more proactive in his own physical health. That'll come when he's a bit older. But also what's nice is, because I'm aware now of us having CMT in our family, and because I'm a reproductive biologist by training, we can think about family planning decisions in a very different way when the time comes for him. But also, I'm hoping that when the time comes for him, we'll have some treatments. So, we can talk about what those potential treatments are, I think. But it's going to be a very different landscape for him living his life with CMT than it was for me, not knowing for a very long time. But yeah, it's an interesting journey, and I think without my CMT diagnosis, I wouldn't have ended up in this role for the CMTA, where I can now use my science and training. So the two things really come together quite nicely to hopefully feel like I'm able to make a difference, not just my family's CMT, but to every family with CMT.
Since 2008, CMTA's Strategy to Accelerate Research, also known as CMTA-STAR, has invested more than $30 million towards CMT research. What has that impact meant for the CMT community, and what does the future of CMT research look like?
Well, that's a massive question that you've just asked there, Chris. I suppose CMTA-STAR is one of the biggest program that the CMTA runs, and we're so committed to our research. We do all of that through STAR. It's easier, I think, to sort of break it down into chunks, thinking about what STAR is, what it does, the people that are involved, and what it means to the community. So, like, where we are at now compared to where we were. So when STAR launched in 2008, there was a small handful of people working on CMT, mostly academics. There wasn't very many biopharma, biotech company partners working within CMT yet. And that's just because the research landscape wasn't really supportive of that just yet. We were limited in the number of CMT models that there were. And by models, I mean cell lines and animal models. And I think we'll come to talking to the toolbox a little bit later to dive into that a bit more. But that ecosystem wasn't really there, and the CMTA, through that 30 million investment over the last 15 plus years, has really created that ecosystem. And the result of that has been more people than ever working in CMT. So academic labs, companies, the list of alliance partners, the biotech people who are working on CMT has just been growing and growing and growing. It's the biggest it's ever been. So I think that's been the impact, and that's just been steadily, like one project at a time, one new cell line at a time, one animal model at a time, has just been working away. And I think sometimes myself, and of course our community, sometimes that progress feels frustratingly slow. You think, well, it was launched in 2008. We've known about CMT for years. We just don't even have one approved therapy yet. And don't get me wrong, I feel that frustration. I'd love research to go faster, but it's just the way that scientific research works is just biology is difficult. The human body is difficult. How we respond to treatments is different. And we have to be really certain that these treatments have got a really positive risk benefit, which means they're going to do us more good than the potential harm that they could cause. So it's careful and it's diligent science and it's moving forwards. So I think we've had a lot of that growth. I said we can see that in the number of partners that we're now working with in CMT research. You can see that in the size of the toolbox, which we'll come to, and we can see that in terms of the number of clinical trials that we now have in CMT. So a lot of this work had to start off as really basic bench research. So understanding what CMT is, understanding the causes, the genetic mutations. Until we really knew all of that, you can't develop a treatment. So a lot of that basic work had to be done first, but we have lots of those targets now. We have technologies rapidly advancing, and what we're trying to convince is more different research labs and companies to say, hey, if you've got a really cool technology, we think this might work in CMT, we've got everything ready for you to come and work on it. So come on, work with us. We've got the models, we've got the patients, we've got the interest, we've got some funding. Why don't you come and try your treatment? And I think one of the biggest things that STAR can do for the CMT community is drive that research, and it gives our community hope. We know that treatments will come. I think about myself and the generations of CMT in my family and my son, and I'm 100% confident there will be a treatment available in my lifetime, which means there is going to be a treatment available for my son, which means when he comes to think about having his own children, crossing fingers, there'll already be a treatment in place. So it just changes that whole landscape. What I'm really hoping is we should get the first approved treatment for CMT across the line in the next couple of years. And in doing that, we're really making sure and proving that the ecosystem we've developed works. There is an infrastructure, there is a pathway to get these treatments across the line. And that then opens the doors for others, because other companies, it's difficult to be the first. And there's only a few companies that are prepared to roll their sleeves up and be that first to get across the line. And what we're doing is making sure that that's shown, that path is there, and we can bring other companies along with us. But I suppose it's really important to just remember that we can't do this alone. The only reason the CMTA was able to spend the millions of dollars on research to get that ecosystem ready to bring those treatments and companies in is because of fundraising from our community, and our community stepping up to fund that research, be partners in that research, roll up their sleeves, answer surveys, talk about burden of disease. We could talk a little bit more about that under patients as partners in research, but it really has been a community effort. And I've only been in my role we've been nearly 3 years now. I feel like I'm very much standing on the shoulders of giants. The work that's been done since the first discovery of CMT1A and the causative gene for that was all the way back in 1981. I happen to know that was 43 years ago because that's the year that I was born. And the work that's been done since then, and the work that's happening now, it's such an exciting time for research and the technology that's moving along. I mean, it's great to see what potential there is now, and the work that the CMTA has done to make sure CMT is at the front of more researchers' minds. It's on more companies' lists of, that's an indication that we would like to go after, and we can see how that would develop a treatment that could be successful.
Now, CMTA's STAR Advisory Board brings together the best of the best from around the world. What is the makeup of the CMTA STAR Advisory Board, and how they play a role in shaping the future of CMT research?
Well, the CMTA STAR Advisory Board is around 30, and I say around because there's an evolution of that board, but there's around 30 of the world's leading experts in CMT, and that covers all of the different disciplines. So we have our STAR Advisory Board is broken down into 3 sub-boards, I suppose you would call them. We have the Scientific Advisory Board, or SAB, and they are academic, institution-based research scientists in laboratories, and they're really focusing on the basic science around CMT, the mechanisms by which CMT works and how it affects the cells, which then result in the symptoms that we see in our bodies. So that's the Scientific Advisory Board. That's chaired by Professor John Svarin, who's based at the University of Wisconsin. And then there's other scientists on that panel that are spread all over the world in their labs, working away on CMT. The other board under STAR is the Clinical Expert Board. And as it sounds, they're all the clinicians. So they are the doctors who are working in the hospitals, who, when you go to a CMT clinic at a CMTA Centre of Excellence, you might see one of those doctors, and several of them sit on our Clinical Expert Board. That's co-chaired by two amazing doctors. So we have Dr. Michael Shai, who's at the University of Iowa, and Professor Mary Riley, who is at University College London. So we have two international lead clinicians involved in the Clinical Expert Board, and a raft of other clinicians at different university hospitals. They're usually also training new doctors in CMT, and they look at that clinical side of CMT, how it affects us as patients on a day-to-day, year-to-year basis. And they're also the sites of clinical trials that are coming up and happening in CMT. So it really links together the CMTA with the clinicians and the clinical trials that are happening in their hospitals. And then the third element of our board is the Therapy Expert Board. So these are really what we call the translational specialists, people who have expertise in taking a potential treatment from the lab into clinical trial, so all the way through that drug development journey. So there might be medicinal chemists in there, which is such a cool job. So they look at the chemistry of the molecules involved and see whether or not they would likely to work based on the chemistry. And like it's people from biotech companies who've got experience of drug development. So they sit on the other side of the fence, the more commercial partner side of the fence. So these three boards, SAB, CEB, and TEB, those three boards work together to help us drive forward CMT treatment development, to help us understand CMT and how it affects patients. And without that three-way lens, we need all of those boards working in partnership to drive treatments. And that's what the STAR Advisory Board gives. I bring them together every month. We review new projects. They look at those projects through their individual lens, and we're able to then choose the ones that are most likely to have success in CMT. And the board is evolving as technology evolves. For example, we added a CRISPR specialist in the last couple of years. We've added people from industry whose companies are just sort of coming into looking at CMT to our board. And that really helps to make sure it's up to date with current technologies and current expertise. And it's also global, because in rare disease, people working on CMT are spread all over the planet. So what we tried to do is bring them all together under the one board to help foster collaboration.
This year, CMTA has a goal of securing 1,500 new patients as partners in research profiles. Describe CMTA's Patients as Partners in Research platform and what it means for the CMT community.
So, Patients and Partners in Research platform is a really unique opportunity for the CMT community to get involved in research, to be part of research, and to contribute to our global knowledge base on CMT. So we've currently got over 7,000 individual patient profiles. That means 7,000 members of our community have stepped up and they've filled in a questionnaire and they are now involved in our research programs. So I'm really proud of how it's grown over time. It was launched back in 2018, so before I joined the CMTA, and I've come in to curate it and help analyse all of the data that comes in, and it's just wonderful to see how each individual patient makes that contribution. It's now the largest global patient-reported data set, which makes it a really powerful tool in CMT research. It started off on a 22-question survey, and we learn about people's CMT, what type of CMT they have, what subtype of CMT they have, the 40% of people who don't know because they've been checked, but at the moment, we don't have a genetic cause for around 40% of CMT. So that's really powerful information. We also know about what age symptoms started, what age were diagnosed, and that's called the diagnostic odyssey, which can be 10 to 15 years in CMT, which is really frustrating, but it's really useful for us to know that. We know how many people have been for a genetic test. So we've learned all sorts of information about people's CMT that's really useful. And the most important piece with that knowledge and information is we can then match those people who filled in that profile. We can match them with research opportunities. So we can say, hi, everybody with CMT1A, there's this really useful survey we need you to fill in. We need to find out your opinion on this potential new type of CMT treatment. Would you be willing to have this treatment? It doesn't commit you to having it, but it answers all sorts of questions and says, this is what the treatment would look like. Is that something that will be acceptable to you? And that helps to drive drug development. We've had questions around breathing and CMT, the impacts of COVID on CMT. We have natural history studies that are studies within the clinical centres, within the doctor's office, that are tracking CMT symptom progression over time. Those studies can't happen without CMT patients getting involved. So far we've helped to recruit to more than 35 different research studies with knowledge and information that's helping to drive CMT research forwards. And that's, like I said, all the way through from a survey to a clinical trial for treatment, like the one that's been run by Applied Therapeutics, the one that's been run by NMD Pharma, where patients are rolling up their sleeves and be the first people to take an experimental treatment. So the Patients as Partners in Research platform has enabled that. Without it, we wouldn't be able to signpost all of our community members to opportunities to help that research going forward. One of the things I found is the way we talk about a Patients as Partners in Research platform. The CMTA youth have been doing a really wonderful job through their Shooting Stars episodes in explaining what Patients as Partners in Research is. So if I haven't done a good enough job, then I would definitely say have a listen to the Shooting Stars episodes, because the teenagers are absolutely wonderful at it, and it really explains that platform and how you can get involved. What's nice is how CMT research and treatment development is progressing is what's happening in the Patients as Partners in Research platform over the next year is I can see more opportunities coming down that pipeline. I can see the opportunity for us to ask more questions of our community. It costs nothing to fill in a Patients as Partners in Research profile, but anybody with CMT can do it from wherever they are in the world, and they have a chance to shape CMT research and help us move that research forward.
In addition to CMTA's Patients as Partners in Research platform, CMTA's preclinical testing network is another tool to accelerate CMT research. Discuss the preclinical toolbox and how it supports CMT research.
So the preclinical toolbox, I think of it like the toolbox you'd find in your dad's garage. You go in there and there's just a treasure trove of useful things in there. And if you didn't have that toolbox, you wouldn't be able to get your next project done. So if we open up the CMT toolbox, what's in there? I mean, it's not your traditional sort of hammers and nails and tape measures. What we've got in there are research tools. So we have a large collection of cells. So these are what are called stem cells. The correct science name for them is induced pluripotent stem cells, which sounds very fancy, but it's just a way of saying the type of cells in your body that can, in a laboratory, be turned into any cell type. So they're super useful. So we've had CMT patients who rolled up their sleeves and they've said, yep, you can take my blood. And the clever people at the New York Stem Cell Foundation can take those blood samples or small, tiny skin punch biopsy samples and turn them into stem cells. Those stem cells are then stored carefully at the New York Stem Cell Foundation, and they're available to different researchers all over the world. And we know, I think it's about 37 different companies now, and that number will probably go up by the time this podcast airs. 37 different companies and research labs have drawn on those stem cell lines, have said, hi, can I have some? And they're using them in their laboratories to test treatments and therapies. And it's really useful to test in patient stem cells first, because it gives you an idea in that petri dish as to whether or not that treatment's going to work. And it's cheaper, quicker, and easier to test potential therapies and ideas and test out your hypothesis in a dish with cells than it is to do it in an animal model. So we always like to start in cells. But also in our toolbox, we have to have some animal models for CMT. And that's because the FDA and other regulatory agencies around the world insist that any potential treatments are tested in animal models first for safety and efficacy. And efficacy is, does it work? Does it help to treat the disease? So they have to be tested in animal models first. And I remember talking to my sister about this topic, and she was like, seriously, so there's a mouse with CMT? And I'm like, yep, they've made a mouse that has CMT, and they have it do these little experiments like walking across a balance beam, or going on a little sort of mouse equivalent treadmill, or gripping onto some wire to see how strong it can grip. So if you think about when you go to your doctor's office and they're like, walk here, walk there, stand up, sit down, grip this, all of those types of experiments that they do on us as people in the doctor's office, they can have the mice with CMT do the same types of experiments. And I see little videos of these mice doing these experiments, and I'm just like cheering the little mouse on as it's trying to stumble across this balance beam and not fall off. And we have animal models, mice or rats, for CMT, for all of the common CMT types. And that just gives us a way to test if a CMT treatment is working. And I've seen videos of mice before they had a treatment and then mice after they've had a treatment, and they are skipping across that balance beam. Well, they don't skip because, mice don't skip, but what they are the equivalent of skipping. And it's just great. I think I'm one of the people on the call that's just cheering them along. And it's just wonderful to see the impact of the treatment. So we can test in cells, we can test in animals, and we're also developing some really cool tests with the cells as well. So we can take the stem cells and we can turn them into neurons, which are the cells that are affected by CMT, all of our motor neurons. And we can have those neurons growing in a dish, and we can visualize them under advanced imaging techniques, and we can watch the cells inside the organelles, the little things inside the cells, moving around and doing the things that they normally do inside cells. And we can watch and see how they're developed. So what we call these is assays in a dish, or experiments in a dish with the cells. And that's the third part of our toolbox. So we have the stem cells, we have the animal models, and then we have these assays in a dish where the nerve cells are there and we're able to test the treatments on them. And this toolbox that we have is unrivaled. We've got 17 different stem cell lines, 6 different animal models, and these assays in a dish. And that's why companies come along and say, how can you help us test our treatment? And we say, here's the toolbox, let me talk you through it. And they choose, depending on what their treatment can do, we help them choose which is the best animal model or cell line to start in. And by doing that, we're supporting more companies to test their treatments in CMT.
We'll be right back.
Register today for the 2025 CMTA Patient Research Summit, presented by Applied Therapeutics. From September 5th through the 7th, join hundreds of CMT community members, along with world-leading researchers and clinicians in Indianapolis. It's your chance to connect, learn, and be part of the future of CMT research. Learn more and register now at summit.cmtausa.org. And now, back to the show.
In September, CMTA will be hosting the 2025 Patient and Research Summit in Indianapolis. I know we're early in the planning process, but what can attendees look forward to at this incredible event?
So the CMTA Patient and Research Summit is always one of the highlights of my year. And the first day is always around help for today. So how you can live well with CMT and what support is available to do that. So I know we're going to be including some information around surgery options, because quite a few people with CMT need surgery on their hands and feet to help with sort of structural malformations that have happened over time. Bracing, lots of our community wear ankle and foot orthosis and different styles of those to help them with their balance and walking. And exercise, because so much research that shows you can help to improve your symptoms of CMT through exercise. So it's about what exercise helps, how to engage in it, and really just encouragement as to why that's useful. And we also planning to have a section on gadgets, because as I mentioned earlier, those of us with CMT, infinitely adaptable, but we use tools and things to help us with taking temperatures, feeling wetness, opening and closing jars. Like there's goes so beyond that to just any activities of daily living where we have experience of what different tools and gadgets can help. So we'll be showcasing some of those. So that's usually what we cover amongst the Saturday elements. And I always find something handy in that helps me, or I think of my dad, whose CMT is a bit more progressed than mine, and I think, oh, that could really help him. So I then get in touch and say, I've seen this really cool presentation or this really cool gadget. So I always come away with something fresh that's going to help me or a member of my family. And then the Sunday, I mean, I'm not allowed to play favourites on the days, but the Sunday is the STAR Sunday. So we have all of the research, and I'm responsible for helping to put that programme together. And what we do is we look at, okay, what's really happening in CMT research right now? What are the big questions that our community has? And we try to answer those questions in a really community-friendly manner. So I know we're planning to have the clinic team from the Indianapolis Centre of Excellence come along and talk to everybody who's there. So there'll be an open discussion to talk with the whole clinic team. I know we're planning some informal roundtables where we're going to have opportunities for people to pick a table that's really of interest to them. And that might be for people who are newly diagnosed, patient parents, because we know this is a multi-generational disease. So if you're a parent or a carer of someone with CMT, you're going to find allyship there and support. And also thinking about mental health and wellness, because that's a big part of living with a progressive, degenerative, chronic disease is, how do you keep mentally well and strong as you're navigating this over time? But then also we will have a broad overview of what's happening across our research projects. The CMTA is supporting over 30 projects. Don't worry, we don't do all 30 projects in deep dive detail. We thank the Lord we've got our website that covers our project in that much detail. But we'll be supporting the highlights and what's been happening at a top level over the last year. We're going to do a bit of an explanation of how treatments get from the laboratory into clinical trials, which helps us all to understand why it takes the time that it does, but also showcasing some of those that really have got that far. So thinking about what clinical trials are happening and what opportunities there are for our community to get involved. We'll talk a little bit about treatments that could treat more than one type of CMT, because there is we're up to over 160 different subtypes of CMT now. We're not going to do them all one at a time. What we look for is treatments that can treat multiple types of CMT. We call those subtype agnostic therapies. So we're going to talk about that a little bit. We also know people have got questions about genetic therapies. So CRISPR is a buzz term that lots of people are hearing about. Could CRISPR be used for CMT? The answer is yes. So we'll talk a little bit about CRISPR and other types of genetic therapies that could be used to treat the underlying genetic mutation of CMT, because it can be quite complicated to think about, well, how does that happen and is it safe? So we're going to talk a little bit about that. But also what we will really do through the summit is we focus on the potential impact of that research so far and provide information that's really relevant to all of the CMT members in our community. So right the way through from that basic research, and I mentioned what's happening now in clinical trials. And what we're really hoping is to be able to put some of our industry partners in front of the patient, so the companies who have treatments in clinical trials now. So we're inviting them along to talk to the patients as well. And I'll also get a little chance to talk about patients as partners in research, which I've just talked about on this podcast, what the current opportunities are, how people get involved. And we'll have a live opportunity for patients to fill in a profile whilst they're at the summit and really become a part of research while they're at the summit, which I'm really excited about. So yeah, that's a sort of top to tail of what we're hoping to bring to Indianapolis. I've never been to Indianapolis before, so I'm really hoping lots of our community are going to come down, join us for that weekend. I also heard there might be ice cream and other nice things to get involved with whilst we're down there.
Excellent. Yeah, and if folks want to learn more about the 2025 Patient Research Summit, you can visit the website at summit.cmtausa.org. Information will be there. Register today, and we can't wait to see everyone in Indianapolis. That's a wrap on episode 3 with Dr. Katherine Forsey. Thank you for joining us on the Simply CMT Podcast presented by the Charcot-Marie-Tooth Association, and we appreciate all that you do for the CMT community.